Hi guys, welcome back to the channel. Jag here, and in today's class what we're going to cover is Science 10, and this is our Science 10 content on optics. What we're going to cover today is going to be about the mirror equation. Alright, so with that, let's get started. Alright, so on this paper is where we're going to actually try some of our questions. This is what the mirror equation is, okay? So I'm going to write it out here. It's 1 over dO plus 1 over di equals 1 over f, okay? So now you're probably wondering, what are all of these variables here, okay? So let's define it first, okay? So f is basically known as the focal length, okay? The focal length is going to be the distance from the mirror to basically that specific point, okay? Now, if you look at dO in the equation, this is going to be the distance, okay, of the object. Okay, and this is the distance of the object from the mirror, okay? And lastly, we have di. Okay, and di is going to be the distance of the image. Okay, and one more time, this is the distance of the image from the mirror, okay? So let's try like an example here, and we're going to try using this equation, okay? So the question says, determine the image distance in each of the following situations, okay? I have a converging mirror. Okay, and the converging mirror has a focal length of 15 centimeters. So I'm just going to write down what's given in the question, okay? And the object is placed 40 centimeters from the mirror. So this is going to be the distance of the object is 40 centimeters, okay? What we're going to do is apply this formula, okay? Now, if you look at this formula, I'm going to be looking for the di, which is right here. I'm going to underline it, okay? And I'm just going to rearrange this formula, okay? So let's write 1 over di, which is equal, okay, to 1 over f minus, okay, 1 over dO. So just like this. So this is my equation, okay? I'm just going to plug in the values into my equation. So the focal length is 15, so 1 over 15 minus 1 over 40, okay? And so again, if you want, you could do a common denominator here. Let's do that. I'm not going to look for the lowest common denominator. We're just going to times this by 40. And on this side, I'm going to times it by 15. Okay, and again, the reason we're not doing a common denominator here is I'm just going to look for the exact value. Okay, so 1 times 40, so 40 minus 15. Okay, that's what I see on the top there. Okay. All right, and then we're going to do the common denominator here. So 15 times 40, which is 600. Okay, and don't worry about it being a fraction, and I'm not going to really reduce it here, okay? So I have 25 over 600, okay? After I subtract it on the top for the numerator. Okay, and again, this is going to be 1 over di, okay? So as you see, what we're looking for is just the value of di, okay? I'm going to just flip this over. And the same thing with the fraction. So if I take the di to the top, it's now going to be 600 divided by 25. Okay, and that's what we're putting in our calculator. Okay, and we are getting 24 centimeters. Okay. And this is all you're doing. This is actually the distance, okay, of the image. And this is distance of the image from the concave mirror, okay, as it is a converging mirror in this example. Okay, does everyone see how to do that? All right, okay, so let's try one more example here, okay? So we're going to try using this same formula one more time, okay? So determine the image distance in the following situation, okay? I have a diverging mirror. Okay, and then I'm given the focal length. Okay, so the focal length is given to be negative 20 centimeters. Okay, and notice because it's a diverging mirror, that's why the focal length is actually negative here. An object is placed 10 centimeters from the mirror. Well, the distance of the object is 10 centimeters. Okay, and I'm looking for the distance of the image. Okay, so maybe we could just put di and then put a question mark. So one more time. Okay, I'm going to write out the formula here. So 1 over do and then 1 over di equals 1 over f. Okay, and the teacher will always give you basically the focal length. And the distance of the image is always given as well. Okay, you're usually just looking for the di value. So one more time, I'm going to take the do to the other side. So I have 1 over di and then 1 over f minus 1 over do. Okay, so this is the equation so far. And now we can just plug it in here. A little bit of simple math. Okay, you see how the actual focal length is negative 20. You can put the negative on top. Minus 1 over 10. Okay, I'm going to do a common denominator here. Okay, so we could just multiply this by 2. I can see the common denominator here is 20. Okay, so this will be negative 1. 1 times 2 minus 2 over 20. Okay, so I'm left with negative 3 over 20. Does everyone see that? And again, this is 1 over di. Okay, so what I'm going to do is just flip this over. And I'm flipping over the fractions here, okay? So because I'm looking for just the value of di. Okay, so it's going to be 20 over negative 3 here, okay? And when you divide it on your calculator, okay, I can see that this is a decimal, but that's okay. The value has to be negative here, okay? So we're going to round that to negative 6.7 centimeters, okay? Now I notice that the distance of the image, okay, here is negative, so I'm just gonna box my answer, okay? The distance of the image is negative. That just indicates on which side of the mirror, okay, your image is going to be forming on. All right. Are there any questions here? Okay, so that looks good. So with that, let's try one last example, okay? And in this case, what we're going to do, okay, so let me put example here. I'm going to read out the question, okay, and I'll write down what is given here as well, okay? And what we're going to find is basically not just the distance of the image, but we're also going to do the magnification as well, okay? In some questions, you have to look for the height of the image. So a woman looks at herself in a magnifying, I have a converging mirror. Remember, the converging mirror is basically a concave mirror, okay? And because this lady is looking at herself in the mirror, so I know it's one of those compact mirrors, okay? And she is looking at herself in the mirror. The focal length is given to you. The focal length is 20 centimeters, okay? And her face is 10 centimeters from the mirror. So this is distance of the object, okay? And the object in this case is her face. Okay, and the question is at what distance from the mirror is her image? We're looking for di here. Okay, so I'm just going to write out the equation that we wrote before. So it's going to be 1 over f minus 1 over do. And you're just going to plug it into this formula here. So we're going to do 1 over 20 minus 1 over 10. Okay, which looks quite similar here. We're going to times this by 2 times 2. Okay, so in this case, it's going to be actually 1 minus 2 over 20. So it's negative 1 over 20. Okay, one more time, this is 1 over di. So what I want to do here is just flip this over and flip over the second fraction because I'm only looking for di. Okay, so if you want, you can put like 2 arrows so you remember. So di is equal to negative 20 over 1, which is negative 20 centimeters. Okay. So therefore, the distance of her face or of her image from the mirror is going to be negative 20 centimeters. Okay, and the reason the distance of the image is negative here is because it's being formed on the opposite side of the mirror. Okay, so here I'm just going to put A. Okay, whereas part B is asking you for what is the magnification of her face. Okay, so when you're doing the formula for magnification, it's negative di over do. The whole formula is actually equal to hi over ho. Okay, hi is actually let's put the height, okay, of my image. Okay, whereas ho, okay, this is actually the height of the object. Okay, all right. So if you look at this is the magnification, is basically how big or small is the image itself. Okay, and so what we're going to do is we can use basically just one part, okay, of this equation. So I'm going to make a circle around it. This is what I want to use, okay? And the reason is because I have both di and do, okay? So I'm going to put negative, and you notice di is negative 20. So you're basically putting the negative sign 2 times, divided by do, which is equal to 10. Okay, the 2 negative signs cancel out. It's going to be 20 divided by 10, which is positive 2, okay? And this is what the magnification is equal to. So the magnification of her face is basically 2 times greater, okay? So I basically know that her face is between the focus and the mirror. And that's why it's actually magnified. And the image is actually positive. Remember, it's forming behind the mirror, okay? But the image is going to be upright. So this is the very last scenario of the concave mirror, okay? All right, so that looks good. I hope everyone did understand how to apply the formula today for the mirror equation, okay? And make sure you're just basically checking your answer over, okay? Make sure all your values make sense. Whenever you use this formula, okay, you should be doing a common denominator just like in math because it's a simple fraction, okay? But you're just subtracting these fractions together. And the reason you do a common denominator is so you get an exact value, okay? All right, so that looks good. And so if there are no questions, that brings this video to an end. Thank you for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone in the next video. Thanks, bye.